Hello guys, we're going to be going over valence electrons today. And your valence electrons are going to lead into the Lewis dot structures. And this is what's going to be part of the beginning of bonding. And so what is bonding? That's where your elements come together and break apart. You actually have chemical compounds, all right? So before we can start that, you have to know what a valence electron is. And that's the outer shell of basically your atom, which is the last part of your electron configuration. Okay, so let's go ahead and do an example right now. A little trouble holding this still, but this is the way I can kind of do the PowerPoint and my lesson at the same time. Let's take sulfur as an example, and let's go back to your original configuration. It's your 1s2, your 2s2, your 2p6, your 3s2, and your 3p4. The 3's your outer energy level, and that's your valence electrons. Your S plus your P gives you that total. So that 2 plus the 4 electrons gives you a total of 6 valence electrons. Okay, this is the rest of your core electrons, and that's going to be on the inner part of your atom. So your total valence electrons here would be 6. Okay. Okay, so now if we have oxygen, oxygen is 1s2, 2s2, 2p4. That last energy level is the S and the P of your last energy, or the 2's. So now 2 plus 4 gives you a total valence of 6. Now you're going to notice that in each group, the valence is going to be the same. Now it's going to be a little different if you are in the D section, but let me show you something else real quick. Okay, let's do a different example. So if you have something like, let's say Mg, which is magnesium, you're still in the third period, so it's going to be your third energy level. You don't necessarily have to do your 1s2, let me write this on a different color, 1s2, 2s2, 2p6, 3s2. Okay, and this is where it ends, right? Because you're in the third energy level, you're in the S section, and you're on the 1 second square. Okay, and so this is your last energy level. So remember, it's your S plus P that gives you your valence electron. Here your S is 2, and there is no P, so it just stays as 2. Okay, now how can you do this without having to do the entire electron configuration? You can just look at your periodic table. You start from left to right. I have 1 square, I have 2. Those are my S's. This is where I stop. So my valence is 2 for magnesium. I don't necessarily have to do this, okay? So now let's do something else, like, let's do that oxygen that we did earlier. It's in the second period. You do your S's, 1, 2, and then your P's are 3, 4, 5, 6. Your valence is 6. This is exactly what we got in the earlier example. But you see how you didn't have to do the electron configuration? So let's say you're down here at 10. Instead of doing that big, huge, long configuration, let's use the black one now. Here are your S's. You're in this period, in the 5th period. So here you have 1, 2, 3, 4. And so my valence is 4 for Sn. Okay? Now, because of your group trends and because you have similar reactions, you have the periodicity is the same every time you're in the same group. Every group is going to have the same number of valence electrons. So let me show that to you. Here's the periodic table with your groups. So group 1, they all have 1 valence electron because they have that S1. Group 2 has 2 valence electrons because they're at S2. Now let's go to something like we just did oxygen. Okay, your S was 2 and your P was 4, so that 2 plus 4 gives you that 6. But you see how all of these will have 6? It doesn't matter what period you're in, you're still going to have the same valence electron. And because you have the same valence electron, that's why they react in a similar way. Okay, so let's take oxygen. And let's make this a little smaller if we can. If we take oxygen, because you have a valence of 6, that means that the Lewis dot structure is going to have 6 dots. So you have 1, 2, 3, 4, 5, 6. And this is your Lewis dot structure for oxygen. Okay, so now let's go ahead and put a compound together. And how do compounds come together? Well, if you have hydrogen, let's find out what your valence number is for hydrogen. Hydrogen is over here in the S section. Okay, hydrogen is over here on the valence. Okay, let's try this again. I'm trying to make it right. Okay, hydrogen is in the S section, and so it has a valence of 1. Oxygen is over here in the P section, and it has 1, 2, 3, 4, 5, 6. So oxygen has a valence of 6. All right. So now, once you have the valence number, you have the Lewis dot structure, correct? So now hydrogen is going to have 1 valence electron, and oxygen is going to have 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay, now, because it's a covalent compound, we're going to show that to you later. This actually bonds right there. Okay, and that'll be in a future lesson. Okay, so now we can add another hydrogen because oxygen has another space that it can share. And so that's how you get your H2O. Okay, and this is why these valence electrons and these Lewis dot structures are important, because you're going to be able to figure out your chemical compound from there. Okay, so the first thing is the valence electrons. Now, if you're in the D section, it's going to be a little different. Okay, so let me do one of those examples, like let's do chromium. Chromium is right here, Cr. Well, if I'm in the D section, and this would be 1, 2, 3, 4, it stops at 3D4, correct? That means you had to get through 3S2 and 3P6 to get to that D section. So that means your S plus your P will always be 8. So if you have your D, whatever it is, 8 minus 4, because you landed at 3D4, okay, 8 minus 4 is going to give you 4 valence electrons. Okay, so chromium will have 1, 2, 3, 4 dots, unless you have a charge. If I have chromium with a +3, then that's going to change. So let me show that as well. Your transitional elements can have different charges. So for example, chromium can be a +3, which means anytime you have a plus, you're going to actually lose those 3 valence electrons. They will bond with someone else. Okay, they're going to transfer. Let's say we do something else like vanadium. Vanadium can be a +3, can be a +5. So vanadium, let's say we do a +5. That means you have 5 dots. 1, 2, 3, 4, 5. You have 5 valence electrons. Okay? And basically, that's it. That's all you're doing. You need to find the valence electron to know how to do the Lewis dot structure. Okay? Let's go back to something like aluminum. You have your S's, 1, 1, 2, and then 3. So aluminum would have 1, 2, 3 valence electrons. Okay? Okay, now let's do a Lewis dot structure where two elements bond, okay? Nitrogen is right here, and you have 1, 2, 3, 4, 5 valence electrons. Your valence is 5 for nitrogen. So nitrogen is going to have 1, 2, 3, 4, 5 dots. Now, keep in mind that you can never do something that's just dots all the way around, okay? You can only have 2 dots per each side, okay? You can have a paired electrons like here, or you can have unpaired like here. And that means you're going to be able to actually pair them with a different element, okay, like bromine. So now let's do bromine. Bromine is over here in the halogen area. So I have 2 S's, 1, 2, and then my P's, 3, 4, 5, 6, 7. So that means I have 7 valence electrons. I always double on the opposite side. I leave a free space that's closer to my element here, okay? Now these are 2 nonmetals, and nonmetals will share electrons, so that means this electron will share with that electron, all right? And that's why those are paired there. Okay, let me undo that so you can see the dots. Okay. Let's go ahead and add another bromine. Bromine still has 7. 1, 2, 3, 4, 5, 6, 7. Okay, and these 2 will end up sharing. Now we still have an empty space here, so we have to, let's get rid of this real quick so we can have some space. And here's another bromine, and you have 1, 2, 3, 4, 5, 6, 7 Lewis dots or valence. And so here you have these 2 electrons will share, and that's how you have NBr3. This is your Lewis dot structure. Okay, if we're still confused, we can have a class discussion right now.